Everybody is seeing my screen, the shared presentation. Yeah,
I can see it. I think that.
All right. Okay, well, good morning, and thanks for joining. So this session is about trusted software supply chain. Right? So my name is Michael, and I'm a specialist solution architect at Red Hat. So today we're going to talk about basically how to secure a CI/CD pipeline. So we'll start by looking at why it's necessary to do that now. Then we'll look at what elements we need to secure a pipeline. And we'll look at the Red Hat products that support those elements. Basically, we'll talk about three probably relatively new concepts: signature, SBOM, and provenance, or attestation of provenance. I'll show you the signature and the SBOM locally on the command line of my laptop. The provenance, I'll show you directly that on an OpenShift cluster because it's easier there, and you'll understand in a few minutes, you'll understand why it's easier to do it from there directly. Basically, what I'll do is that I'll start a pipeline, a secure pipeline on an OpenShift cluster, and we'll have a look at what is created and how to have information from what has been created. So the two products that will be the focus of today's presentation are Trusted Artifact Signer and Trusted Profile Analyzer. But although it's not the focus of today's presentation, we will also have to give a few words about Quay, ACS, Advanced Cluster Security for Kubernetes, Git Sign, Developer Hub, a few other products that are satellite to the main ones of today's presentation. So why do we need to secure the CI/CD pipeline? You've probably saw those statistics already, which demonstrate that the number of attacks on the software supply chain is increasing exponentially. Actually, it's not only the absolute number of attacks that is increasing, it's more about the scope of the attack that is actually of a concern. Because indeed, a lot of companies use cloud technology nowadays, and it creates a new and very attractive, actually, attack surface, especially the software as a service application, the SaaS application, because indeed, if you can hack a SaaS application, you potentially have access to thousands of customers at the same time, all of those using that application. Right? And in addition, open source has become quite the leader in innovation and cloud services. I'm sure you read the news, especially in the AI domain, with all the open source models now, DeepSeek, Kimi, Devstral, and all that stuff. And with open source, the attack surface is even more attractive because you have access to the code. If it's not access, at least you have some kind of visibility on the source code. So the kind of attack that is of a concern today is the attack concerning the source code, which leads to malicious code being built by a traditional CI/CD pipeline, which are blind. And this malicious code is simply deployed in production by traditional pipelines. So let me maybe give you some examples. You probably have heard about them because they had a lot of well, there were a lot about them on the news. It's not super new. The examples I'm going to give you are from 2020, 2021, 2022, this period. So the first one here is Code Cove. So Code Cove is for code coverage. So it's an utility. It's a bit like SonarQube, and it's available as a SaaS application as well. So technically, if we go into the details, it uses a bash upload script, which uploads reports to a remote server. And this script is in a private, or was in a private Git repository. The agent, which is shipped as a container image, download that script because there might be some updates on the fly. And because the agent is shipped as a container image, the agent was available on Docker Hub. And someone was able to retrieve from within the image on Docker Hub the credentials of the private Git repo where the bash upload script was. So basically what they did is that they changed the IP address of the remote server, and all the reports started to be sent to a fake server. And of course, those reports, they contain information such as environment variables and things like that that are useful for a hacker. Another example is SolarWind. SolarWind, it's more a monitoring system. It's also shipped as an image. And from time to time, there is an update. So a notification is sent. The agent image is aware of the update and updates itself automatically. So here, someone someone hacked a Microsoft 366 account. So it's a very traditional attack on the network. But this account that was hacked had permissions on private repositories. So what they did is that they created a fake update, and all the clients installed that fake updates and started to send information to a remote server. So same principle. Right? So there are many examples like that. This one is a bit different. It's not really an attack. It's a vulnerability issue, simply. But it shows, I use this example to show that there's also a need to protect not only against potential attacks, but also against vulnerabilities, which are simply something that is not made on purpose. It's just in the code, there is a weakness that can be exploited. So the log4j, if you want the details or the technical details, it's a library that read logs, right, from files usually. And as part of the logic in the runtime, there is a JNDI call that is made to retrieve classes and then to execute the code of the class. And actually, the weakness in the runtime is that it's possible to write lines of logs in such a particular way that they would be interpreted by the JNDI call. So by doing that, you could have the JNDI call getting a class from a remote location and execute the code of that class instead of the code of a class that would be local. And I'm not an online gamer, but I read on internet that on the Minecraft online game, there was a way to execute code by writing specific commands in the chat box, because the chat box is logged in a file, and then it's logged by log4j. And it was possible, apparently, to execute things simply by writing with a specific format on the chat box. Well, now let's look at what exactly we need then to avoid those kind of problems that we've seen. So basically, the requirements are that we need to make sure that the source code is from a known origin and it hasn't been tampered with. We need to make sure that the image, because we are in the world of containers, so the image is from a known origin and hasn't been tampered with. The image basically would be the source code. We also need to have a way to register all dependencies. And, well, we need a way to protect against fake updates. So this part I want to talk about that today because, yeah, we have a limited amount of time. But I provided here a link if you want some more information about that. It's more a second level, I would say, in the protection of a CI/CD pipeline. So for the build process, so the protection, the securization of the CI/CD, there's a specification that has been created. It's called Salsa, so for separation levels of software architects. It's still evolving, I would say. It's not completely finalized, especially the level 4. And it can be also quite complex in the details, but here I'm just going to propose a simplification. So the level 1 would be that the build is scripted and there is a provenance document. We'll see what a provenance document contains. The level 2 would be, there is a build server. So the build is scripted, but it doesn't run on a laptop, for example. So it's scripted, but there is a dedicated build server. And the provenance, not only it exists, but it's also signed. So we know who created the provenance document. Level 3 would be the build server is isolated from the rest of the infrastructure. The build script, so when we say it's built as code, it means that the build script or the build code has everything that you can expect from, for example, from something in a Git repository. So it has a history. You can go back, see the changes. So it's built. The build script. The build comes from a code, and the code has all the history and traceability that you can expect. And the provenance is non-falsifiable, which means that there is no way to change the provenance document and have it re-signed. And it sounds weird when it's said like that, because you would say, okay, if I change it, then the signature will not be correct anymore. And you'll see that actually you need to pay attention to that, because we will see that you could actually change a provenance document and have it behave like it was completely correct. And the level 4 is about hermetic build. So the build is isolated, but it's also disconnected. That's what it means by hermetic build. So it doesn't connect to anything. The provenance document not only tells you what is the provenance of your own code, but it also tells what is the provenance of all the potential dependencies that your code could use. And the build doesn't contain any parameter. So it's completely black box script. You cannot alter what the build script does. We're not going to spend too much time on the level 4, because at the moment we speak, Red Hat provides you everything you need to achieve level 3. And we are working on providing everything you need to achieve level 4. But level 4, as I said, is still a little bit being defined. We already have things that would fall into the category of the level 4 security. We will see that. But we will focus today on the tools that will make you achieve very easily the level 3. Because indeed, Red Hat is a very active company in open source and in cloud technology. So providing solutions to our customers that are secured is a top priority for us, and providing to our customers a way to do the same for them is also a top priority. Right? So the project we invested in to achieve that are Trusted Artifact Signer. So if you look upstream, the name upstream is Sigstore. So you have the upstream name Sigstore, and then when it's the Red Hat product, it's called Trusted Artifact Signer. And then you have Trusted Profile Analyzer, which upstream you will find named as a Syft. Right? But it's not only Syft, but Syft is maybe the core element of this part. Now, if you take those two products and you add Developer Hub, you will find a bundle called Trusted Application Pipeline. Basically, that's what it is. The Trusted Application Pipeline is basically Artifact Signer, Profile Analyzer, and Developer Hub. And we will see why Developer Hub, even though it doesn't appear to be a tool related to security, has a big play in that area as well. And then if you want the full story, if you add to that Podman Desktop and OpenShift Dev Spaces, you have another bundle, larger bundle, which is called Advanced Developer Suite. Okay? All right. And yeah, another tool that is not part of those bundle is ACS. You had a session, I think, dedicated to ACS, but so we're not going to redo that session, but it's going to be part of the solution I will be presenting. So we also have ACS on the picture. Okay, so profile analyzer would be what we would use to deal with SBOM, which means everything related to vulnerabilities. An artifact signer will be what we will use for signature and attestation. Attestation is not written here, but signature and attestation will both rely on artifact signer. Okay, so signature. So you probably already know the principle of signing something. So the purpose is identification. So in security, we say non-repudiation. So it means that if you sign something, you cannot say that it wasn't you, right? But that's exactly what it means. So it's based on traditionally, it's based on a pair of keys. You encode with the private key and you expose the public one. And if someone can decode what you encoded, it means that it's you who encoded it because you own the private key. And the way you expose the public key is you put it into a certificate, and then you have an authority that says that indeed it's your and it's a valid public key, so that no one can actually replace it with a fake one. Okay. Now the problem with this model is that you need keys, and if you leak the keys, something bad will probably happen. Yeah. So we need a way to simplify the use of signatures, which means to simplify the use of keys, because indeed the examples that I presented at the very beginning of the session would have been prevented probably if someone had verified, if it had been signed and someone had verified the signature. But usually what happens is that signing using keys is something that, well, it's not easy, it's not comfortable, so usually people just don't do that. People skip this part. Okay, it's signed. I'm not gonna check if the signature is valid. If a tool doesn't do it for me, I'm not gonna do it manually. Right? So what is the solution here? Well, the solution is simply to give the ability to sign something without using keys at all. And the component that provides that feature is called Cosign, and it's part of the Sigstore project. So if you remember, Sigstore is the upstream name for Trusted Artifact Signer. So it's an umbrella project. Part of this project, there is an element, a component called Cosign. So how does that work? First, you need an OpenID Connect server. That's what it will be based on. So the OpenID Connect server is there to provide identity management, to provide identities. Right? So you log into your OIDC provider, and what you get in return is a token, right? Normal. This token will be used to generate a pair of keys. Right? So it acts as a kind of a root key. Right? It's just that you don't need to manage it. It's an OpenID Connect feature. And the generated key pair here will stay, so the big difference is that it will stay in memory only. It will never hit the disk. Right? From there, it's the same principle. You encode with the private one, you expose the public one, and so on. Right? Now here, the thing is that because it's in memory only, the public key will at some point disappear. So later on, when you need to decode, you need to retrieve that. We need a way to kind of retrieve that key that theoretically would have disappeared. So the first thing is that the key is still exposed via a certificate. So the certificate authority in that case is called Fulcio. It's also part of the Sigstore project. It's tightly linked. It will be configured to be linked to your OpenID Connect server, so it can verify the identity of the owner of the key. So Fulcio here it's like a Let's Encrypt. If you know Let's Encrypt, it's just that some technical details are different. For example, Let's Encrypt, if you look at the validity, it's 90 days or 60 days, 60 or 90 days. For Fulcio, it will be 10 minutes. So there are some details that are like that differs, but same principles. Kind of a let's encrypt for ephemeral signature keys. Right? So I was saying this key, this certificate, well, the key that the certificate contains will disappear because it's in memory only. At some point, it disappears. So what do you do? That you place this certificate into a ledger database. So a ledger database it's an append-only transactional database. So when you need to verify the signature, you can query that database to retrieve the certificate that existed at a specific moment in time. And the timestamp that is inside the certificate will be stamped as well with a timestamp authority, right? So there will be the certificate here, and then the timestamp will all be certified. So let me show you exactly how it works. So I'm gonna go on the command line to do that. Yeah. Okay, so you can sign. So I'm going to show you the keyless signature. So you can sign. Yep, sorry, my keyboard doesn't. Yep, all right. You can sign whatever you want. Okay, so you can sign any kind of binary. So here, for example, I have a file, basic file. With some text, right? Okay, and I can. It's a binary. I can sign that, right? So to sign it, I'm gonna use the Cosign command line. Let me take it here. So it's Cosign and then sign blob, the name of the file, and then I need to provide the client for my OIDC server. So so it opened my OIDC provider here, so I can sign in. I think it's GDO, and correctly. Yep. And once I am authenticated, and it's going to provide me to sign it. So here on the command line, I have the certificate that contains my key. It says here, so here it's the signature, right? And it provides here, you see tlog entry created with index. So basically it's the index at which my element is registered in the database. The database, which is provided with Trusted Artifact Signer, is called Recall. So I can actually use the Recall client. Yeah. And then the log index, it says that it's 0. So if I do that, recall key get, log index, and then the URL of the recall server, which is installed as part of Trusted Artifact Signer, I will get the JSON document that corresponds to the signature. So here you will see so the signature that we show on the command line is the same as the one here. So signature, the content is here. And the public key, if we decode that, well, we can do that. That's the certificate, basically. Yep. That's a certificate. And we can check that it's exactly the same as the one that was presented on the command line. Now, I add the log index, so I just query the database based on the log index. But if I don't remember what the log index was, I can also search based on the username, because I know who is supposed to ship that file. So I can search based on the email of the user, GDO, and I will find the same the same entry. So it's gonna give me the UID, and with this UID, I can retrieve the information. So just do then get and then the UID, Oops, sorry. And here we want to replace this one with this. And it's going to give me the JSON document. Okay. And we can check with verify. So if I do, let me copy that. So I can also do now a Cosign verify blob to verify, and then I need to pass. Well, I need the certificate. Sorry. So first I need to take the certificate here. This one. I'm going to put it in a file that will be easier. Up. Okay, so now I can do verify. The name of the file, the certificate, and the signature, which was the one here. Yep. And it's going to say that it's okay. Now, if I modify the file, and I verify it again, it's going to say that it's invalid, right? Normal. So you can sign whatever you want. Of course, what you would be very likely to sign is an image. So here I have one. I have deployed an application. Yeah, so I have an image and I have an image stream. Yeah, okay. Okay, so this is my image stream. You can see that it's just that one tag, the 1.0 snapshot, and that's it. Just one layer, one image. And I can sign that as well. Just maybe before I sign, there is a more beautiful way to see the security element, which is with Cosign tree. But here, of course, it's not going to find any real security-related artifact. But if you have multiple signature for multiple layers, that would be much easier to see it with Cosign that simply with the image stream, even though in the image stream you will also have the information. Okay, so now let's sign this image. So here I'm just, instead of saying sign blob, I'm saying just sign, and sign is for images. And then the URL of the image. And here it expects a full image. So I'm going to use this with the identifier here. So in theory, it opens the SSO page with the OpenID Connect of the OpenID Connect server. Here, because I have logged in already and my session is still open, it's automatic. It doesn't ask me to relog. It's a single sign-on. And now, if I inspect the image again, you will see that the image now contains a .sig layer, which contains a signature of the image. And I can see that with the describe as well. Okay. So you have the normal tag, and then I have a .sig, which is added on top of the image. And you can retrieve that, you can check that, you can do a verify as well. Same, instead of doing verify blob, you will do verify. Same thing, the identity, and then the image. And it's going to tell you that the image is valid, it's signed, and the signature is correct, and it will give you all the information that you need. And well, I hope you will believe me if I tell you that if you modify that image and you try to verify, it will say that the signature is not valid. But it doesn't correspond to what's inside the image. Okay. All right, let's go back to the slides. Yeah, the SBOM.
Michael.
Yep.
I would like to make sure that this concept is clear. Also to verify if I understood correctly. So basically, when someone who is in charge of signing the image launch the command to sign the image, at that time it has to log in the OEDC in the single sign-on system, and the Cosign tool add a new layer on top of the registry with the signature.
Exactly.
Okay, so this is the.
So it means that later on, if you want to use this image because when you create the image, you are probably in development, right? Later on, if you want to deploy that image in production, you can verify that actually it's not an image that has been modified.
Okay.
So
one important point is that the person there should be the building is in charge of a user. So at least someone who started the building process has the responsibility to sign the image. This is a point that it can be something that is fully automated. I mean.
Exactly. So you could do that manually. So you could indeed in your CI/CD process have a manual step where someone signs the image, but ideally it's part of your pipeline. So your pipeline starts by a Git clone, that gets the code, it builds the image, and it signs the image, and everything is done in your pipeline. Ideally, that's fully automated.
Okay, so in that case, the identity who signed the image is an automatic. Let's say is a system identity in that case.
Exactly.
Okay.
Exactly. Yeah.
Okay. Perfect.
Okay.
Clear.
All right.
Good.
The SBOM. Well, I'm not gonna talk about that. Do a lot of theory about that. I'm going to just show you. I think it's easier to understand if I just show you directly. So the SBOM is to actually deal with vulnerabilities. The idea here is to be able to know when you build an application what it uses, what packages it uses, so that if tomorrow someone says there is a vulnerability in that package, you can easily retrieve which one of your applications are actually using that exact package, right? So I'm just going to show you. I think it's easier it's easier like that than to do theory about it. So it's the upstream. It's the Syft project. So you have a Syft command line, Syft command on the command line. Similarly, you can process, you can generate an SBOM of whatever you want. So for example, here, this is the source code of the application that I deployed. And you can actually generate an SBOM based on source code directly. So if I do that, so Syft, and then what I put is directory, this directory. And then I'm just saying the name of the file that I want the result to be in. So it's going to take a very short time because it's a very small application. And it's going to generate a JSON document. I'm not going to do VI because it's not for pretty print by default. I'm going to do that. It can be a very, very large file if you have a lot of dependencies, of course, but basically what it says is that it says all the packages that your application is using. So it means that tomorrow someone says there is a vulnerability in that package of that version, you can easily, because those, we will see in a few minutes that all those SBOM, you can export them into a server, and then from the server, in the UI of the server, you can search. So you can easily identify, okay, all those applications are using that version, so I know that I need to apply a patch on those applications. Okay? So here you can do that for a source code. So here, Java source code. So it's gonna list a lot of jar files, obviously. But of course, you can also, what you would want to do is to do that with an image as well. Right? So you can also do same thing, but here you type the URL of an image. So that's the image, that's the same application, but it's the image now, so it contains the operating system in addition to the Java packages. So here it's gonna take a little bit more time. Let's just give it a few seconds. Yeah, it's done. So again, it created a file. This one now. So if I use, so similar, it's a similar thing, a list of all dependencies. The difference here is that because it's an image, it contains also the operating system. So you will see that it will list also the RPM in addition to the jar files that it could find, okay? Which would be your jar file in that case. Okay? So you can generate an SBOM for the source code, an SBOM for the image. The tool allows you also to merge two SBOM into one if you want to have only one. And once you have those files, the best practice is to, of course, upload them to a server where you can use them. But best practice is also to have that as part of your image, so that if you can retrieve them later, or if you want to for traceability purpose, it's a best practice to also have a copy on your image. So for that, you can use Cosign attach SBOM, and then the name of your file, and then the image where you want to attach it. Okay, and now if I do a describe of the image string, you will see that it has one more layer, which is the SBOM. Right? So of course, from there you can download that layer, download the file, and use the file. But we will see in a few minutes that part of your pipeline you should also upload it to a remote server. The remote server will be the one provided by Trusted Profile Analyzer in that case, and then from there you have a UI where it's more comfortable to work. All right. So the provenance now. So an attestation of provenance is a JSON document, again, that describes your build process, basically. So it's used to guarantee that an image, in our case, an image, followed a specific build process when it was built. Okay? So it has a specific format. The format as a specification. The specification we use is this one, the int 210, which basically is very simple. It says that it has two parts. The first part is the subject. The subject is the name. So, for example, it's the name in the case of a pipeline on OpenShift. That could be the name of the pipeline simply. And then it has a payload, which is called in that case a predicate. And the predicate is custom data, but most likely that would be the details of your pipeline. And again, if it's a pipeline on OpenShift, that would be the YAML file, simply. Okay? And if you have that, you can actually, so you generate this file, you attach it again to your image, so that someone who has access to your image can download this file and can check that indeed the image was built with those steps and those steps. And because it will be able to retrieve the pipeline details or whatever you had put in the predicate. Okay? On OpenShift, when you use Tekton, and I know you do, this is actually automated and provided out of the box by a component of Tekton that is called Tekton Chains. So the only thing you need to do is to enable Tekton Chains and configure it with a couple of parameters, which is part of the operator. So in the YAML of the operator, you can enable and configure Tekton Chains. And once you did that, the pipeline that runs on your cluster will automatically be signed, and a provenance will automatically be generated. Okay. So concretely, what happens is that in the case of the attestation of the provenance, you have your pipeline descriptor, the YAML file with all the tasks. The steps will be the Tekton tasks. What it does is that it takes a hash of that. The hash goes into the predicate, so that it creates the JSON document, and inside the JSON document, inside the predicate, it put the hash of the pipeline. Then it's signed, and it's added to the image metadata as a layer. Okay? It signs also the image, so Tekton Chains also sign the image automatically for you. So you just need to configure it to tell it what is the user that will sign the image. So it supports, Tekton Chains supports both approaches. So it supports signing without key, so with Cosign, and then you just use a service, you choose a service account to sign. But it also supports hard keys. If you prefer to have your keys in files and use the traditional ways of signing with hard keys, it's actually possible. It would support both. But for it to be able to sign an image, your pipeline run needs to end with at the end of your pipeline, you need to provide two informations: the image digest and the image URL, because it's going to take this digest, sign it, and add it as a layer to the image URL that you put in the pipeline at the end of the pipeline in the pipe heighting. Okay, maybe before. Let me look at the time. Yeah, okay, I'll continue here. So you will have another layer in your image. So at the end, you have the .sig, which is a signature of the image, the SBOM, which is your SBOM, and then you will have a .att, we'll see that as well, which would be the attestation. Okay, so everything is on top of your image. Now, the thing that you need to understand here is that Tekton Chains cannot make the difference between someone genuinely modifying a pipeline, YAML file, and someone maliciously modifying a pipeline. It means it will sign all the pipelines. So you need to make sure when you use Tekton Chains that the namespace where your pipeline runs is protected. That no one has access, no one that shouldn't have has access to it. Yeah? That's quite important. Because if everybody has access to the pipeline, you can just add a step into the pipeline, it will be signed. Now, the thing is that you still have, well, you still should verify that when you use the image. So you should take the pipeline and verify that what was the step. Okay? And you will see if one step was wrong, you will be able to see it. Okay, so now you have an image. You have all the information as a layer. You need to verify those information. How do you verify? Well, I show you that you could verify with Cosign. Cosign verify will verify the signature and will verify the layers. Okay. Now, if you want to go one step further, because when you do Cosign verify, it verifies that the signature exists and the signature corresponds to the image, and it's valid. Okay. Now, you might want to go one step further, and you might want to say, okay, I want to verify that the signature exists. I want to verify that the signature is correct, but I also want to verify the content. For example, I want to make sure that inside the signature, the username is exactly that one. Okay. If you want to do that, you need to add a little bit more intelligence to the standard Cosign verify, and this is called enterprise contract. The enterprise contract is just a command line. It's called EC. It's based on Cosign, but it adds the ability to define policies. Like here, you see you have minus policy, and in the policy it's a JSON document where basically you declare what you want to check inside the JSON document that is verified by Cosign verified traditionally. Okay. All right. Now we saw how signature work. What is an SBOM? What is an attestation of provenance? We had a look at Tekton Chains. Now let's look maybe at what is our at Red Hat opinionated implementation of all of that. So this is usually the pipeline that we propose. So once again, it's our way of thinking about a secure pipeline. Doesn't mean that you might differ a little bit, right? It's okay, but our way to think about a secure pipeline is that. So you have the pipeline that builds the image, and then you have other pipelines that use the image for deployment. Okay, so the steps that we use are those ones. So from of course, Git clone is the first. Then we have a commit check. I'll talk about that in a few minutes. We still haven't talked about the commit check. Then we do a source scan, so scan of the source code. Then we build the image. We provide an attestation. We sign the image as well as the attestation. And we generate an SBOM or two SBOM, depending on what you want. If you want one specific for the source code, one specific for the image. So we generate an SBOM and we upload an SBOM to a remote server in addition to put it into the image. We do some dependency analysis. So it's another capabilities or trusted profile analyzer. And so once you have the SBOM that lists all the dependencies, you can run a tool to check those dependencies. Then we do a build check, image scan, deployment check. That's to build an image. At that point, we have an image that is correctly built and that is secure. And if we want to use that image to deploy something, we have the signature, the provenance and signature check before we promote that image to the next environment. Okay? So now here is exactly the same pipeline, except that I put everything on the same diagram. So on the left side, the big one is the build pipeline, and I added to the right the beginning of the promote pipeline that does the signature check. It's just to have everything on the same in one page. And here this slide is to show you what are the tools that we personally use to implement that pipeline. So let's talk about the commit check later. The source scan, we use SonarQube. So build, test, assign, build, sign, and create an attestation and sign an attestation. We leverage Tekton Chains to do that, and Tekton Chains uses Trusted Artifact Signer. Usually we do that with the keyless method. So we select a service account, and the service account has a token that comes from the OpenID Connect server that OpenShift itself uses. The SBOM and the dependency analysis are the two steps that are done by Trusted Profile Analyzer and Syft. And the build check and the deploy check, if you remember the session about ACS, they are done by ACS. So you have policies in ACS, and you have build policies and runtime policies, right? So that's where we leverage ACS, and that's why ACS was on the picture at the beginning of the presentation. The image scan, well, you can do that with ACS as well. But here, simply because we used Quay as our registry in our demos and in our workshops, it's easier for us to simply use the Quay security operator. And then the provenance and the verification of the signature, we do that with enterprise contract. So all of those are steps in our Tekton pipeline. Yeah. All right. Just a few words about the satellite products that you can hear about when you hear about Trusted Software Supply Chain from Red Hat. Developer Hub, first of all. So why is Developer Hub bundled with Trusted Artifact Signer and Trusted Profile Analyzer in the Trusted Software Supply Chain project? But it's because it's going to be of great help to standardize your pipelines. Right? That's the main objective of this tool. It's to provide standardization. So what you do, I don't know if you've heard about, so it's Backstage Upstream. Don't know if you heard about this tool, but basically what you do is you define with YAML files again an application provisioning template, which means that when you create an application, a Java application, a .NET application, whatever application, this tool creates the files for the application. So it can be a Quarkus template, an EAP template, Spring Boot template, but it also creates OpenShift components at the same time. And the typical OpenShift components that it will create is the pipeline that will build the application template that has been created. So it will create the application template and the pipeline that builds this application at the same time. So it ensures that any application that you create will be built by the pipeline that is standardized. You will have all the application built with the same pipeline, and you can decide then to define the pipeline with all the security checks that you want. So you could do that manually, of course, with each time you create an application, you can duplicate an existing pipeline and so on. But this tool will save a lot of time by automating this process. So I'm not entering into the details because actually you could have a dedicated session only for this tool. It deserves its own hour of talk, I think. But yeah, basically what you need to know is that it's a tool to standardize the application management and build process, and it will save time, particularly if you build and deploy with OpenShift tools such as Tekton and Argo CD. What I will do is actually I will show you the results. I'm not gonna go into the details, but I'm gonna show you the results once you have created an application with Developer Hub. Where is it? Yeah, here. So I'm just gonna trigger one application. I think there is one already somewhere. Secure. Yeah, secure in a Quarkus service with Tekton. Yeah, I'm just gonna create one here, and we'll see what is the result. I'm gonna use Quay. And I think everything is fine. It's gonna take a few minutes, so while it's doing that, I'm just gonna continue here. Yep. All right. ACS, okay, you had a dedicated session. We saw here that it's used to perform builds and deployment checks. So I'm I'm not going to go back onto that, but just to give you some examples, a build check could be to verify that when the image is created, it doesn't contain any more tools like, I don't know, curl or DNF, which are actually tools that an attacker could potentially try to exploit, right? So usually what you do is when you build an image is that you use a staged builds, because when you build, you might need DNF or you might need curl, but at the end of the build process, you delegate the result of the artifact that has been built to a runtime image that doesn't contain those elements or those tools. If you don't do that, well, you can use ACS to alert you that the build process didn't use a runtime image, but used a build image. And as a result, you might end up in production with command line tools inside the image that could be exploited. Okay, so that's a typical build check. A deployment check or runtime check could be, very basically, it could be to verify, to ensure that when you promote an image to pre-production or production, it's not going to use the latest tag. So your deployment config cannot by mistake use the latest tag, because the latest tag presents a little risk, which is that if there is a new version, it will automatically apply it. And you might, if this new version is not under control, you might deploy something that you don't want to deploy. So a basic deployment check would be, okay, the deployment config in non-development environment uses a proper tag, a proper image tag, and not the latest tag. Yeah? So Quay, well, we use the scanning capabilities of Quay. It comes from an operator, and the good thing is if you use the operator, is that the result of the scan then will be visible directly on the OpenShift console. So, well, now if you don't have Quay, you use something else, but yeah, just to show you that in the case of using the security operator, you have direct access to the information that, on the OpenShift console, and you don't have to switch from one tool to another. And the last thing that I would like to talk to you about is Git Sign. So we saw that we skipped the Git Sign in the pipeline, in the description of the pipeline a few minutes ago. And it's to highlight, actually, it was made on purpose to highlight one thing that might be a constraint or not, but something important to be aware of is, so Cosign, so Git Sign, what is Git Sign first? It's the same thing that Cosign, so it's to sign without keys, but instead of being a command line tool, it's a Git plugin. So you configure your Git utility with this plugin, and as a result, each time you do a Git commit, the commit is automatically signed. So the very first time you will have to log into your OpenID Connect provider, but once you're logged in, every single commit that you do will be signed. Now, the reason why it's skipped in the pipeline that I described a few minutes ago is that you need, where it can become a constraint is when you need to verify the signature, right? Because you need to be linked to the same OpenID Connect provider than your pipeline. And it might not be the case. If you use GitHub, for example, if you are experimenting something and you're using some code that is on GitHub, then probably when you did your Git commit, you used your GitHub account, which is not the account that OpenShift knows. So you just need to make sure that in terms of single sign-on, you have either the same one or a federation that allows you to verify the commits of your Git repository. Yeah. And then I think that's all I wanted to say. I'm going to go back to the OpenShift Web Console to show you the result of the pipeline in a minute. maybe I will just finish with that two last slides before I go back to the OpenShift console. Just to tell you what's next in our work in trusted software supply chain, of course, we are trying to add some, we are adding some AI capabilities to our tools and to make the use of the tool easier. And we are working on the level 4 specification and the tools that are needed to complete to be compliant with the level 4 specification of Salsa. But one thing we already have is if you want to do a hermetic build, so a build completely disconnected from any environment, we have a tool called Cache2 that is actually used to prefetch dependencies, prefetch project dependencies, and that allows you to, so you add that as a step in your pipeline, and that allows you to do all the rest of the build process completely disconnected from any remote server. And it also has the capability out of the box to create the SBOM that would list all the dependencies that it prefetched. So you give your application, it's going to analyze your application, prefetch everything that your application need, generate the SBOM automatically, and then all the build process will be done offline. All right, so for the slides, that's all I have. I'm going to go back to the OpenShift web console. So in theory, the pipeline should be complete, hopefully. Yeah, it's here. So we can look at the details of that pipeline. So we have basically everything that I have explained. So you see that when the SBOM is created, we upload it to the TPA, Trusted Profile Analyzer server. And then this part is ACS. If I go to the pipeline run now, you see, so those information here comes from the image scan because I use the Quay operator. So I have direct access to this information here on the OpenShift web console. I don't have to open any files. I don't have to go to anywhere else. Now for the management of the SBOM, that's Trusted Profile Analyzer. So you can actually search for SBOM. You will see the SBOM of my Quarkus application is here. And then you can, from there, see what packages you use. You can see you can have a report about what issues could be found, or what indirect access to the remediation. If you see that there are some critical things, so for example here, I have Maven utility that says that there's a vulnerability. One. And then you have directly the access to the CSV and to the remediation, which basically the remediation, I guess, would say that I need to update to the latest version of this component. Okay. Well, for introduction to securing a CI/CD pipeline, that's basically all I wanted to show to you. So if you have any question, I'm happy to try to answer them.